All right, guys, so today we're going to be factoring with the greatest common factor. Now, if you remember, greatest common factors would be like the highest number that I could divide two different numbers by and still get a whole number. So like let's take 18 and 6. So we want to think of the biggest number that both of them could be divided by and give us a whole number. So start thinking of factors like 2 would go into both, 3 would go into both, and 6 would go into both. The biggest one that we could use there would be 6. If we divided these both by 6, I'd get 3 and 1. That's basically what we're doing today, but we're also going to do it with variables, okay? So let's move over to number 1. I have 15m squared minus 9. Now, first I want to look at my numbers and think, what's the biggest number I could take out of both? Well, 15 and 9, some numbers that go into both. Well, 1 would, that doesn't help us. 3 would, and there's really no other numbers that would work. So I'm going to write 3 out here. Now, next we'd look at the variables. But since both of them don't have variables or the same variable, we can't take any out. So I'm going to open up parentheses. Now I'm going to take my number and divide it by that 3 that I took out. 15 divided by 3 is 5. And since I didn't take out any variables, the m squared stays the same. Now I take the negative 9 and divide it by 3, and I get negative 3. There's your answer. Now, if you're correct, if you go back and distribute your 3, you should get the exact same thing. So, for example, 3 times 5 is 15, and then the m squared, which is what we wanted. 3 times negative 3 is negative 9. These match, so that means we're good, okay? Now, there will be certain cases where maybe you didn't pick a big enough number. You might have to look at your numbers again and make sure you're finished. But other than that, that's all there is to it. So let's look at number 2. Now, first, I look at my numbers. I have 5 and 10. Well, the biggest number I could divide both of them by would be 5. But now, both of the terms have an x. 5 has x squared and 10 has an x. You want to take out as many x's as you can, but you can't take out more than the least amount. So if I look over here, I have an x squared and an x. I can take out an x, and that's all I can take out, because if I take out more, I won't be able to take it out of this term. Now I'm going to open my parentheses. Think about numbers first, then variables. 5 divided by 5 would leave me 1. X squared divided by x would leave me x. Now you could just write x. 1x is just as good. Plus 10 divided by 5 gives me 2. And x divided by x gives me 1. So it cancels out. And my answer is 5x times 1x plus 2. Now, if I multiplied that out and did my distribution, 5x times x would be 5x squared. And then 5x times 2 would be plus 10x. So that's how you would check it. It looks like we're good. I'm going to check my numbers and make sure there's nothing else I could do to divide out, and it looks like there's my answer. All right, let's go to number 3. Now, we're going to have more terms than just 2 in number 3. We need to look at all 3 of the numbers. I have 4, 6, negative 6, and 14. We'll start with the lowest one. The only things I can divide 4 by are 4 and 2. Well, 4 won't go into 16 or 14, so I go back to the 2. That looks like it would work. So I pull out a 2. Now I have x to the 5th, x to the 3rd, and x. Since 14x only has one x, I can't take out any more than that. So there's what I'm going to factor out. Now I start with my numbers. 4 divided by 2 would give me 2. X over x to the 5th divided by x would give me x to the 4th. Now I have negative 6 divided by 2 gives me negative 3, and x cubed divided by x gives me x squared. 14 divided by 2 gives me plus 7, and the x divided by x cancels. There's your answer. Now you can also check this with distribution. You might want to check your numbers, 2, 3, and negative 3 and 7. There's nothing else I can do, so I'm finished. Let's move to number 4. Number 4, my numbers are negative 8 and negative 12. Now the first thing I notice is they're both negative, so I'm going to pull out a negative. I have 8 and 12, so let's see, 2, 4, and 8 would work for 8. 2 would work for 12, but so would 4. 8 wouldn't, so I'm going to take out the 4, the biggest one I can. Now let's look at our a's. I have a squared and a. Since this only has 1a, I can only take out 1a. I have b and b squared, but again, I have a smaller one of b, so that's the most I can take out. But both of them have c squareds, so I can pull that out as well. Now I open up my parentheses. Negative 8 divided by negative 4 would leave me with 2. A squared divided by a would leave me with a. The b divided by b would cancel out, so I wouldn't have a b. And c squared divided by c squared would cancel out, so I don't have any c's. Move to the next term. Negative 12 divided by negative 4 would give me positive 3. A divided by a would be nothing, it cancels. B squared divided by b would leave me a b. And c squared divided by c squared would cancel. There's your answer. Okay? Now move to number 5. I have 3, 9, negative 9, and 6. Well, the only things that will go into 3 are 3 and 1. Luckily, 9 and 6 are both divisible by 3 also, so I pull out a 3. All three of them have an x value. The biggest or the smallest x value is this x squared, so I can pull an x squared out of each. And it looks like my last two terms have y's, but my first one doesn't, so I can't take out a y. So there's my factor. 3 divided by 3 gives me 1. X to the 4th divided by x squared leaves me with x squared. Negative 9 divided by 3 gives me negative 3. X cubed over x squared leaves me an x. And since I couldn't pull out any y's, it stays the same. 6 divided by 3 gives me positive 2. X squared divided by x squared cancels out. And then I have a y squared that I couldn't take away. There's your answer. So go term by term, piece by piece, and these are not near as bad as you might think. Let's go to the next one. Number 6, 15x cubed y squared z plus 20x squared y z squared. Start with the numbers, 15 and 20. Well, it looks like 15, 3, 5, and that's about it. If I look at 20, 3 won't come out of 20 evenly, but 5 would, so I'm going to pull out a 5. Let's look at our x's. I have an x cubed and an x squared, so the most I can take out is the x squared. I have y squared and y, the most I can take out is y. I have z and z squared, the most I can take out is z. There's our factor. 15 divided by 5 leaves me 3. X cubed divided by x squared leaves me with an x. Y squared divided by y leaves me with a y. And then z divided by z cancels, so I'm done with that term. 20 divided by 5 gives me positive 4. I have x squared divided by x squared, which cancels. I have y divided by y, which cancels. Z squared divided by z would leave me z to the first. There's our answer. Now, I went through those kind of quick, guys. Those aren't very difficult. If you need help, you've got to come get it. You're not just going to get it automatically if you don't understand it. You need to ask for help. Now, we have a couple of review questions after this. The first one, number 7, the perimeter of a rectangular garden is 42 feet. The length of the garden is 6 feet more than twice the width. Find the length of the garden. So the first thing I need to do is realize I'm looking for length and width. So L and W are my variables. To find perimeter, I would have to take 2 times my length plus 2 times my width, and that'll equal 42, what they told me the perimeter was. Next, I know that the length of the garden is 6 feet more than twice the width. So the length is bigger, and it says 6 feet more than twice the width. That gives me 2W, and the 6 more adds 6. So this is a substitution problem. I know what L is. I'm going to plug it in for L in my other equation. So I get 2 times 2W plus 6 plus 2W equals 42. Now I can distribute. I get 4W plus 12 plus 2W equals 42. I can combine my like terms. 4W plus 2W gives me 6W plus 12 equals 42. I need to subtract 12 from both sides. Now I have 6W equals 30. And if I divide both sides by 6, I get that my width equals 5 feet. But they didn't ask us for width, they asked us for length. Well, I can take this 5 and plug it in for that W there, and I'll get my L. So L is 2 times 5 plus 6, which is 10 plus 6, so my length is 16 feet. So be careful. Watch out for the length. The garden is 6 more feet than twice the width. That's what we had a lot of trouble with earlier in the year. Let's go to the last one. Altogether, Rob spent $52 on 2 shirts, including tax. The difference between the costs of the shirts was $18. What's the cost of the most expensive shirt? So I'm going to do this. I'm going to say that S is my expensive shirt. And I'm going to say that T is my cheap one. Now it tells us that if I add them together, I spend $52. So S plus T equals 52. It also tells me that the difference is 18. So if I take the expensive shirt and subtract the price of the cheap shirt, I get $18. Now we can do elimination. Now remember, in elimination, we add up our variables top to bottom, and we want to cancel one out. Well, if I look, the T's are opposites, so they will cancel. So I have S plus S, which is 2S, equals 52 plus 18, gives me 70. I divide both sides by 2, and I get the price of the expensive shirt is $35. All right, guys, I hope that helps out. If you have any more questions, feel free to ask. You really need to get this down because what we do Tuesday, Wednesday, Thursday, and Friday is very dependent on being able to find greatest common factors. Good luck.